My name is Altug KAYA. I'm an electrical and electronic engineering student at Bilkent University, Turkey. This is my EE102 digital circuit design project.
So, before I'm going to show my project itself, I would like to explain my design. There are two ramp sensors, one DC motor, and one servo motor. In addition to these, I would like to say that I'm going to use a motor control driver for driving my DC motor. In this design, I'm going to take inputs from the ramp sensors and then the inputs go to the comparator module in VHDL. Then these module generates a 2-bit input, 2-bit output. Excuse me. This output means that if it's 0, 0, there are no obstacles within range 10 centimeters and 20 centimeters. If it's 0, 1, it means that there is an obstacle on the right side. If it's 1, 0, it means that there's an obstacle on the left side. If it's 1, 1, I'm going to give the priority on the right side. If there are no obstacles, the servo motor will not turn and stand by at the middle position. Obviously, if there is an obstacle on the right side, the servo motor will turn left for avoiding from the obstacle. If there's an obstacle on the left, the servo motor is going to turn to the right. And as I mentioned before, if there are obstacles on both sides, it will turn to the right. In addition to this servo motor, there is also a DC motor for turning the wheels. If there are no obstacles, the DC motor will turn at 80% duty cycle. And you can see that if there are either an obstacle on the right or the left, or even obstacles on both sides, it is going to turn slowly. I'm going to use two different clock dividers for different purposes. As you all know, or probably will know, the pulse width modulation is change the duty cycle of the square wave, and of course change the energy that is given to the DC motor. This is for DC motor. So in this module we are going to change the duty cycle of the PWM signal of the DC motor. However, our servo is, let me write there, SG90 mini servo. This servo would like to see a pulse for every at least, like, of course, at least for every 20 milliseconds. This is approximately 50 Hertz. I'm going to use a 40 Hertz PWM signal for driving the servo. In addition to this, servos are not as basic as DC motors. This is a square wave but a different duty cycle. This width should be between 1 millisecond and 2 milliseconds. 1 millisecond means far left. 1.5 millisecond means middle position. This is standby mode. and 2 milliseconds means far right. So let's see the project itself. Before showing the project, I would like to explain the range sensor working principle. It's not as easy as in the Arduino platform because this, like I'm using a Basis 2 board, it's programmed by VHDL. There are different modules for different purposes for this range sensor. This is the trigger module. Like first thing first, the dash line means that we have two counters for two different modules, so they're not one counter for one purpose, of course. Trigger generator is going to trigger the range sensor and going to reset the counter of the trigger module and the distance calculating module. And each counter will count frequently. It means that this trigger generator will trigger both sensors and modules periodically. However, the counter of the distance calculating module or the distance calculator module will be enabled when the pulse input is high. The pulse input is the echo input of the range sensor. It will be like that. This is the reflection of the ultrasonic sound. This, like when the counter starts to count, it will, when it's resetted, it will send the data to the distance calculating module, and it only works when the pulse is 0. So this counts only when the pulse is high. This calculates only the pulse is low. Then it will generate a 9-bit output which represents the centimeter. And excuse me, please forget this binary coded decimal. I forgot to erase that. This is the only output. This is the robot itself. As I mentioned before, there is one servo, one motor driver, one DC motor, and two range sensors. If we turn the power on, if there is an obstacle on the right side, this is the debug LED. Servo turns to one way. Let me show you again. And probably you can't hear that, but the DC motor sound is changing. For showing this properly, I'm going to show you the PWM signal. This is while it's working at the 80% duty cycle. When there's an obstacle, if there's an obstacle on the left side, the whole process changes. This is the debug LED. Probably you can hear that, you can see that, the green one, and the servo changes its direction. This is on the left side, and this is on the right side. My project is done here. Thank you for watching. Please subscribe, like and share.